collaboration with Dr. Prenti Mandani and AgriLife. And so this is about, I'm going to give some results for a couple of years of the study for the small molecules for mitigation of citrus farming in Texas. So, so I'm so glad that Dr. Hussain went before me because he introduced citrus and a little bit of the varieties and things like that. But today, I'm going to just give a brief introduction about citrus in Texas. So, so our Texas citrus industry, it's located in the southern most part of the state, in the counties of Starr, Hidalgo, Willacy, and Cameron, and that's where our citrus industry is located. And so here I have the logo of the citrus center. So we are located in here, kind of in the middle of this, and we have our research station there on this side. So this is just a little bit of the production. So California would be like the largest citrus producer in the United States. It's about 80%. Florida, it's about 16-17%. Texas, about 2.8%, and Arizona, 1.1%. This is from 2023. And but here, our production in Texas is very much about 60 to 70% of the production that we have in Texas. It's grapefruit. So if we look at grapefruit, even though we just produce 2.8% of the total citrus production in the United States, we produce the value of our grapefruit is even higher than in Florida. And so that can tell you that our industry is big and is strong, and it's mostly focused on grapefruit. So that's kind of like how our market is located. But several years ago, over a decade ago, actually, 2012, this citrus disease, which is called wandering bean citrus green, was detected in Texas. And it causes some discoloration of the leaves, but that's not really the most important thing. The most important thing is that the trees start getting some imbalances like inside in the metabolites, and the roots get a little bit compromised. It's caused by a bacteria, the Bifidobacter, and so the production of these trees slowly become unproductive. So Florida used to be the largest citrus producer in the United States, and because of this disease, the production has been one of the reasons why the production it's being reduced. I mean, there's other factors, but definitely this disease has to do a lot with it. And this is just a small, a map of the distribution of the disease. So in 2018, only it was very located in just very few spots, and then slowly it was spreading through the whole area where citrus is produced in the state. So now it's considered that it's endemic to our region. So if we look at the production of citrus in Texas, so we can see that in varying acres, it was about a little bit over 25,000 acres in 2011, 2012, and 2012, that's when HLB was detected, and this is the total production, and these are the acres. So you can see that it was the production, it was kind of, the acres were kind of steady, and then you have some ups and downs, and then you can see this very steep decline in production, and but of course not everything is because of HLB. So here in 2020 we got a hurricane, so of course the production went down a lot, and then in 2021 we had this freeze event. I don't know if you can recall, Storm Uri also affected our citrus industry very, very much, and so that's why you see this very steep reduction in acres. Of course, there's no planting, but if you know citrus, you plant a tree, and then it's going to take several years, 4 to 5 years, to start producing, and then get into a level of production of a mature tree. But then the first years you don't have very much production. So, but anyways, so we have HLB that is threatening threatening the industry. So, and then we have also some freezing events. how the disease has affected productivity, because we have these other events that have really had very strong effects. So, but something that we did in our lab is that we started looking at HOV-infected and non-infected trees and see how they affected, for example, blooming. Like, are we going to see our trees have less flowers because of HOV? And yes, we saw that there was a reduction. It was not statistically significant, but we did see a reduction. But then the fruit set, we did see a significantly less fruit in the trees that were positive for the disease, even though like, they were blooming the same, but then the fruit was, the fruit set was a little bit lower. And this is just, we did some, a little experiment to see if grapefruit trees that were infected and non-infected, if they had changes in production. And yeah, we could see that some of the HOV positive trees, or the ones that were positive for the disease, did have a reduced yield. Of course, depends on the level of the severity, but we did see some reduction in general on productivity. So, in collaboration with Dr. Frankie Mandadi in AgriLife, he was doing a screening of different compounds that he developed in his lab, an in vitro assay with hairy root system that contained the bacteria. And then he was doing a screening of different molecules to see if some of these ones could be reducing the level of replication of the bacteria, or if they could actually kill the bacterium in vitro. And so there were some hits. So there were 3 new potentially anti-CLAS, which is how we call the bacterium Candidatus Liberobacter asiaticus. And so we call it like CL3, CL6, and CL8. And so basically we're like, okay, so we did some in vitro experiments, and then instead of going into the greenhouse and then going to the field, we just went straight into the field to start testing for this chemistry. So I put the years here, I don't know, somewhere. So this is in 2022, so if you recall that map, we just had our first freezing event in 2021, so in 2022 we started this experiment, so the yield of all of these trees was very low, because the trees were just barely coming back from a very important freeze event. So basically what we did, this is just experimental, so this bacterium, I skipped all of the introduction, so I don't want to take too much time. So this bacterium lives in the phloem of the plants, of the trees, and of course to make this antimicrobials reach to the phloem, we're trying to, so sometimes spraying things might not enter and reach to the place where the bacterium is located. So what we're doing, we're injecting the chemistries right into the phloem of the, well, actually it's not a phloem, injected it into the xylem, hoping that eventually it's going to reach the phloem where the bacterium is located. So this is just a picture of my student drilling a hole in the trees and then placing the syringes with the chemicals inside, so for them to actually go into the vasculature of the tree. And then we're testing our 3 chemistries at different concentrations, oxytetracycline, and antibiotic. That is, I guess it would be kind of, there's only like 2 antibiotics that have been approved for the use in agriculture. So this is one of them, and it has been approved in Florida for use for treatment of this disease. And so we're using that as one of our control, and of course some solvents and water that we use to dissolve our molecules. So so this is just the titers of the bacterium, and so we could see that CL8 and oxytetracycline, those 2 were the only ones who actually can reduce a little bit the titers of the bacterium, basically about 45 days after infection, and then they would just, but then the rest of the chemicals we tested at different time points, and we're looking at the tree if they would have like some sort of effect on the tree canopy, but we didn't see any changes in tree parameters. Like we're looking at the canopy density, or we're looking at the canopy color. So So we didn't see, we just saw a small reduction in the bacterial titers. And, but then we were looking at the